Let's start with interpreting some graphs of f. For question 21, part A wants us to find where f prime is 0, positive, and negative. We can find this by looking at the slope of this graph. To find where the 0 points are, you are looking for where the slope is 0. And that happens at -1 and +1. And f prime is positive from -infinity to -1 and +1 to infinity. This is because the slope is positive. And f prime is negative from -1 to 1 because the slope is negative at this point. For part B, we have to find where f double prime is 0, positive, and negative. We can find this by looking at the concavity of the graph. F double prime is 0 at x equals 0. This is because the graph changes concavity, also known as an inflection point. And f double prime is positive from 0 to infinity because the graph is concave up. And f double prime is negative from -infinity to 0 because this is where the graph is concave down. Using this graph of f prime, we can use it to find when f is increasing. To do this, we have to look for where y is positive for the graph of f prime. So the answer in this case would be 0 to 5. And that is with a bracket on the 0 and a parenthesis by the 5. And to find when f is decreasing, it is the same idea used in part A, except we are looking for where y is negative for the graph of f prime. And for this graph, that happens from 5 to 9. And there's a parenthesis on the 5 and a bracket on the 9. For relative minimums, we just have to look for when f prime switches from negative to positive or at the endpoints. For this graph, the minimum is going to be the endpoints because f prime doesn't ever switch from negative to positive. So the relative minimums are at 9, 0, and 9. And there's one relative maximum on this graph of f, and it is found by finding when f prime switches from positive to negative or at the endpoints. In this case, the relative maximum is at 5 because f prime is positive and then negative. To find when a graph is concave up, you can find it by using the graph of f prime and by finding when that slope is positive. For this function, it is concave up from 3 to 4 and also 6 to 7. To find when the graph is concave down, it is the same process as when the graph is concave up, except you are looking for when the slope of f prime is negative. And for this graph, that happens from 0 to 3, 4 to 6, and 8, and 7 to 9. And finally, to find inflection points, we are looking for when the slope of f prime is 0, which happens at x equals 3, 4, 6, and 7.